Hello and welcome to Do It Yourself Musician. Today we're going to take a look at my Roland DEP-5 digital effects processor. It is acting up, so I need to take a look at it and see if I can fix it, hopefully. Now the Roland DEP-5 is a multi-effects processor. It was introduced by Roland in 1986. It is a 16-bit analog to digital conversion, has a 28-bit internal processing in it, and it does digital chorus. It has a semi-parametric EQ, does digital reverb and digital delay. And obviously with the chorus in there, you can adjust it to get some flanging type effects and everything like that. I use it in my guitar setup and on my recordings, but definitely use it in my guitar setup. I've had one forever. It's a fantastic unit. It's one of Roland's classics. The DEP-5 and the Roland SRV 2000 Reverb. You will still see those in major recording studios inventories around the world because they are fantastic. They sound so great. The DEP-5 in particular is great to use for guitar because it has such a wide range of input attenuation on it. It can easily accept a guitar signal straight in. No need to bump it up to line level or anything. So what's going on with mine is one of the knobs, the control knobs, number 6, is acting up. And the way this unit works is that these knobs, numbered 1 through 7, are rotary encoders. They're not actually real potentiometers. They're digital rotary encoders. And when you turn one of them, it adjusts the setting. You know, say like if you did EQ low, and when I turn that, you would see it adjust over here on the screen, and then you could save that. You could write that to memory, and thus when you recall the different patches in memory, there's no need to move these, and it doesn't automatically reset each patch to whatever these dials are. These dials, when you drop into a memory, say like memory 15, these dials don't mean anything because it's using whatever you programmed into it. Now when you go to touch one of these and move it, it's going to change what's programmed into the unit. Now I'll move number 1 here, and you'll see that it'll say 1, and you'll see the adjustment on it. See, I'm like minus, or I'm going up positive 6 dB, and I'm going, there's minus 6 dB on the EQ. Now you can see right there what the fault is. If you watch, you'll see that number 6 is triggering itself. Let's see if I can get it to do it again. If I move one of these other knobs and let it off, number 6 just triggered itself actually. And what number 6 is, it controls reverb time. So if I'm playing along a patch that has a big cavernous reverb, and sometimes number 6 will trigger by itself, and it'll turn my cavernous reverb into a small room all of a sudden. And I just, that's not going to work. So I need to figure out how to make this thing not trigger itself. So you can see right there, it's just doing it by itself. And every time it does that, it's resetting whatever patch you're on. It's resetting to wherever that knob happens to be at the moment. And it is a little slow to respond when I turn it, actually. Or it was. Right there, it's not even responding as I'm turning. So I'm hoping that it's just the potentiometer in there is just dirty. So I'm going to pull this out, put it on the bench, take it apart, and get to this potentiometer and clean it. And hopefully that'll just take care of this problem. Okay, we've got the DEP-5 up here on the bench. And just so you know, the circuit board inside of the DEP-5, the top of it actually faces the bottom of the unit, so the circuit board is actually upside down in the unit, and where you have this ventilation at, that's where the transformer is. You can see on the bottom it's also ventilated there, and there is on the bottom, if you remove all these screws, this is actually a bottom cover, and you can sometimes slip that out just to service the bottom, the bottom, which is, like I said, actually the top, because you'll be looking at the components of the board from this way. If you look at one of these used, you'll often see that this is bent up, and that's because someone tried to pry this bottom off. It's better to take out all of these screws, take your ears off, and take out the screws on top also, and the top piece will slide off at that point along with that bottom piece. And it's better just to do that, just take everything off so you don't bend the case, and that's what I'm going to do now. Okay, we got all the screws out, I think. I'll go ahead and try to slip this out. It's probably not really something I can do on camera. There's the top cover off, and as you can see, the board is upside down in here. All the screws are the same except for this one that goes in the top here where this brass fitting is. That screw's like a little short, but it's pretty obvious that that's the one that's different. All right, I'm not going to go into much detail about the circuit boards and servicing these things, because this is not really a teardown video or anything like that. I did want to point out though that this is actually an earlier version. This is probably from '86. It seems like I can't find any chips dated after '86, and it's a pretty early serial number. And one thing you can also use to tell kind of what era it was made in, they were only made a few years, I think up until about 88 or 89. But most of them, you'll see these two resistors on there. That's pretty much on every one I've ever seen has these two resistors bodged on here. The earlier ones though have some jumper wires like these here. This one, there's another small one there, and it also, they have these ground strap things, which for some reason disappear on the later models. I'm not sure why, but typically you don't see any of that stuff. Just these two resistors means that it was later in the run. I guess they probably corrected the circuit board at some point to fix whatever those bodges were. And just by way of comparison, like I said, we're looking at, this is the one we're fixing. This is an early probably 86. I've got another one here, and this one is probably 87. I found a couple of chips that have 1987 written on them, and you can see on this one you've got the same two bodge resistors there, but now all those little bodge wires, other ones are gone, and so are the two ground strap wires that are on this one. So there is some difference. You can tell kind of what year you have, whether you have an early one or not. I mean, it's because it's hard to tell just by serial numbers or by looking at the ROM version, because the ROMs are marked with a version on them. But I mean, I've never seen a list, so I really don't know what's what. So you can't really go by that. But you can look at the chips on the circuit board, and plus how many. If you've got all these bodge wires and all your chips at 86, then you probably got an early one, which really doesn't matter. I've seen this one is an early one, and it's the best one I have. It's awesome. My later ones actually are worse than this early one, so it's kind of just a matter of how good a shape it's in. Okay, so anyways, that's about all I want to talk about as far as electronics. It's not really electronics thing. As you can see, we've got our potentiometers up front here, and number 6 is this one here. Tilt it up and get a better look at it. And thankfully, these things have long shafts on them, so they go all the way through the faceplate here. And in order to clean that, I don't know, I might, I mean, it has a hole in it to where I can get to the wipers, so I can probably just put some deoxin in there and try to clean it that way. And I'll take a magnifying glass to the legs on it, on the solder side of the board, just to be sure. So that's what I'll do. All right, I've zoomed in on these potentiometers so you can get a little bit better look at them. And actually take back what I said about these being digital potentiometers. These are actually just regular potentiometers. They're 10K pots here. So they must be using some type of resistance sense circuit to figure out how you adjusted this, because it's definitely not an analog system. So they must be just sensing the analog pot when you turn it, the resistance, and transferring that with a to D converter to figure out where you've got the dial set. Okay, I'm going to try to clean this with a little bit of the Deoxit Fader F5. I'm just going to spray it right down into the little opening on the pot, on the number 6 pot. And you always want to kind of cover this up to protect. Spray back. Doesn't take much to go in there, and work it around a little bit. So make sure to take it end to end on it. All right, I'm going to let this sit a little bit, and I'm going to plug it back in and see if we made any progress. Okay, let's see if that fixed it. No. I would say that actually made it worse. In fact, the pot's kind of really not responding at all anymore now. Well, I'm definitely going to have to take a closer look at the number 6 pot. When have to pull it out of there and take a look at it. But since I sprayed cleaner in it and it's now worse condition than it was, that leads me to believe that it probably is the potentiometer that is the problem. So I guess I'm going to pull it out and attempt to clean it further. And if that doesn't work, I'll have to replace it. Okay, just a little FYI on this. I've taken all the screws out of the perimeter of the faceplate, top and bottom, which allows the whole thing to come off and leave behind all the controls. You can take off just the 4 in the corners of the faceplate and pull the plate off with the display and the buttons and everything. But if you do that, you'll have to unplug the cables that go to the display and the buttons. If you just take all the screws out, you can just pull it off, and which is going to allow me to get to the number 6 potentiometer here and desolder and get that thing out of there. Okay, I've got the knob and the nut removed from this potentiometer, and I'm just gonna desolder it now with the desoldering pump here. Okay, I've got the pot out of there, and I was just checking it for resistance, and it seems to actually work fine. So I think I'm going to go ahead and try to clean it. If not, I might just try to get a new one. The only problem is I'm pretty sure when I was pulling this out of the unit that I lifted a solder pad on it. Unfortunately, it just would not let go. It's ridiculous. Problem is the solder was on both sides of the board, and I couldn't melt it. I just couldn't get to it. And when I was trying to pull it through the board, I had to heat it up to pull it through the board, and I think it lifted up one of the traces a little bit. It seems like it's still intact though, so it's maybe not hopeless yet, but I'm going to see if I can crack this open and clean it up a little bit. Alright, I've got the potentiometer apart, and unfortunately the way they've made this one, I can't really pull this apart. It's not really serviceable. I can't get this plastic wiper piece off so I can investigate more. I can't actually see anything that really looks wrong with it at all, and it reads right on the meter, so I don't know, maybe that's not what's wrong with it. But due to the fact that I lifted the solder pad on this thing, I'm not willing to solder in this one just in case it is what's wrong with it. So I'm definitely going to buy a new potentiometer and solder that in there, because I'm not going to risk further damage of putting this in there and having it not work and then trying to take it back out again. It's just not gonna fly. So definitely gonna got to get a new one of these and solder that in and see what happens. Alright, well, I checked with Roland Corporation to see if they actually had any of these pots available. They do keep a stock of a lot of parts for old units around, but these happen to be discontinued. And I probably could buy one of these just from, I don't know, Mauser or somewhere. I'm sure that I could just get the specs off of it and buy a new one from them. But instead of doing all that searching around and stuff, I think I'm actually just going to steal one off this unit here. This is not the same DEP-5. This is a different unit that I have. And this unit has a lot of issues. It just had really dirty audio. There's some broken input and output jacks and things, and those jacks are actually not available from Roland either. So since this unit is not as good as the one I'm trying to repair, I'm just going to use it as a parts unit and pull one of the pots out of here and put it into the one that does work. And there it is, new pot. So I wanted to show you real quick this solder pad here in the center. That's the one that lifted up when I was taking the defective pot out of this. It only lifted up in this corner though, so I was able to reattach that with a little epoxy. Plus I scraped out the coating on the circuit board around it to expose more copper. So I should have no trouble getting that to solder back in there. I know it looks really crappy, but with these things you just kind of just don't want to touch them too much. Just, you know, it's solid, so I'm not going to worry about it. Just going to put the new pot in there and solder it in, and hopefully we'll have a good outcome on this one. Okay, I've got the new pot in place. It's just here, and I'm sorry if the lighting looks kind of crappy, but I need to see what I'm doing rather than film. So I'm just gonna solder that in there now, and we'll give it a try. All right, that looks pretty good. You can see that a little better. Nice, bright, shiny blobs of solder. Looks all right. Okay, I've put the face plate back on. I put in the bare minimum of screws just so we can give it a test before we put it all the way back together. Still got the top of it off and everything, and I make sure nothing's going to short out here. We'll give it a test. If it doesn't work, I'm probably going to cry. Alright, it's on. Relays clicked over. Remember, it was number 6 was our bad knob, and it's not working. Well, it's very unfortunate that changing out this pot didn't clear that problem up. I do, however, think that was a good thing to try. I mean, you saw the behavior that it had when I tried to clean it, so I mean, replacing it was not a bad thing to do. Though, obviously, it did not correct the problem. So I think what we need to do now is check the schematics and find out where this pot goes to. This is number 6 is reverb time, but the actual component name is variable resistor 4, so VR4 is what we need to look at on the schematic, so we'll take a look at that. Okay, here are the DEP-5 service notes. And if you run down here and take a look at the block diagram, just here. Here's a block diagram. Here is the resistors, the knobs, potentiometers. This is variable resistor 4. That's our reverb time potentiometer that we've been working on, and it flows into the CPU, which is IC 26. Okay, if we actually run down to the circuit diagram here, yeah, let's see, let me bring this up so you can see it better on your screen. Okay, here is VR4 right here. This is reverb time. This is the pot that we just changed. You can see all of these are how they're supplied. The wiper, though, comes off of VR4. It flows up to resistor 128, which is 150 ohm resistor. Looks like there's a cap to ground here, which is C100. That's a 0.047 cap. And after that, it flows down and flows into number 10 on IC26. So it pretty much takes the input directly. So again, here's the reverb time VR4. Flows through resistor 128. Has this cap to ground here, which is 100, and it goes on down to pin 10 of IC26, which is the CPU. So I'll check. We know our potentiometer is working, so I'll check resistor 128 and this cap, and generally look at the traces and everything and see if there's a problem between VR4 and IC26. Okay, I'll flip the unit over to locate where all these caps and resistors were on the diagram, and if you look right here, they're all in a line right here, and that's what all the pots are flowing into. And you can see that R128 is right here. There's a resistor in there, and then C100 cap is right here. So I'm actually going to flip the board back over and measure these with ESR meter and see what their values are, and also check out the trace that goes down to where they are. Okay, here's the other side of the board. If you'll look, this right here is the is VR4, the pot that we just changed, and the signal lead. The trace is coming out here. You can see it's flowing right along here and winds up there. It flows into 128, so that's going to be 128 across there. That is tied to C100, which is here. So I'll check those with the ESR meter and see what we get. Alright, well, I checked the caps here with the ESR meter, diesel multimeter also, and check some resistance values, which they were reading good in circuit here on the resistors, and also check for shorts. I can't really find anything. There is a weird looking solder joint there, but I don't think that has anything to do with our circuit here. Ours comes in here to R128, and it flows out of here. And I traced it just a minute ago. It flows over here, and I think winds up here. I don't know. I traced it just a second ago, but it's weird. It flips to the other side of the board and actually flips back to this side and then back again. Even you can't see it on camera, but it comes over. It basically flows over this way. There's actually a reference point that's a hole in the board right there. It goes to the other side of the board and comes back out to this side, and it flows over this way a bit more and actually disappears back through the board again and comes out really close to IC26 and goes to pin 10. And I can't see anything. Obviously, there's no other components in that line there, so I'm not sure at this point. I do notice that these traces are really, there's a lot of residue on this board. Most Roland boards actually do have a lot of rosin solder flux residue all over them. This is no exception. Some of this is actually turning kind of white, and maybe it's conductive. I don't know. The traces appear to be pretty dirty in this area. So I'm actually kind of running out of ideas here, because the traces, they look good, but I think I might just try to clean them really good. Try to clean all of this flux residue off the trace. I mean, maybe there's some type of small bridge somewhere that's causing this intermittent problem to happen. So I think the next step is just going to be to get some flux remover, and I'm just going to clean this on both sides, this entire trace, and see what happens then. All right, hold the presses. Let's just stop here for a minute. As I was cleaning the board off, and I got to the top side and was looking at the CPU chip, which is what you see on camera right here. The number 10 pin on this chip, which you can just make out there in the foreground. Sorry about the lighting, but I don't really have the best setup to do photography this close. But right there in the foreground, that 10 that you can see, if you look just there, that's the 10. It's facing out 1 0 there. That pin on this chip, that's the CPU chip, the pin right here, that's where the variable resistor 4 winds up at. It goes into the main CPU chip. And I got to looking at that really close, and when I put a magnifying headset on, that solder joint looks really sketchy. Now, I'm going to try to show it to you here, if I can. I know this is like the worst way possible to do this. I don't know if you can actually make that out or not. It's really hard to see, but that chip right there, look at all the solder joints next to it. They have nice fillets on it, but that one seemed to have a greater than 90-degree angle to it. In fact, when I actually got a thin sheet of paper and I was able to stick it into the crack there. I believe that's just a cracked solder joint on that number 10 pin that our variable resistor 4 goes to. So I'm going to try to put a little dab of solder in there and see if that solves our problem. Okay, I just did a little more snipping around. I think I've definitely found a problem here. If you look, there's a set of vias here that are coming from the bottom of the board to the top, and this is the number 10 here. And I've got my probes out and I'm set to continuity mode just to see if there is indeed continuity to this number 10 pin, which there is. But look what happens when I just put a little pressure on the pin. Hear that? Continuity, a little pressure, gone. That's a bad solder joint. If I go over to number 11 pin, I can push on it and I still got continuity. That's definitely a bad solder joint. I'll reflow that with some solder, and hopefully that's going to solve the problem and fix this unit. Alright, well, there is the repair. I know that it's a bit difficult to see, but you can see I've got a little bit bigger solder blob on this pin now. It's about the best I could do. This is a pretty fine pin pitch on this chip. I did check it with the continuity, and it's fine. It has good continuity even when I push on it and everything, and there's no solder bridges here, so hopefully that repaired it. Let's try it out, I guess. Let's cross our fingers. Okay, let's have another look at the circuit diagram just so we can be clear exactly what it was I did. You can see here IC26, which is that Intel chip that's the CPU of this unit. Has the pins laid out around it here. Over here you see the controls on the front panel. This is VR4, that's the reverb time pot. Let me just zoom in just a little bit here. Okay, so what I did is that we know that the VR4 pot is good because we replaced it, and all the other pots work, so I'm not worried about anything in this part of the circuit. So if I trace back, I run into resistor 128, and that's what I did, and I checked it with the multimeter. It's a 150 ohm resistor, and it's good. Then come on down, that's connected with a cap. It's a 0.047 capacitor to ground here. I checked that with the ESR meter in circuit. It read fine. Additionally, I actually checked all the other ones here too, and everything read fine, totally within values, and nothing else. And then I decided to clean all of this circuit pathway that went on both sides of the board several times. And in the act of doing that, when I got to the top of the board, was cleaning this area, I had a good look at pin number 10 on this chip right here, and pin number 10 discovered was actually had a bad solder joint in it. It was broken, which I proved with the multimeter. So I actually went and got a little solder and dropped it into the joint here at number 10 pin, and made a nice little connection there to cure that solder break we had there, and everything looks good. So let's turn it on and see if that fixed it. Alright, I've got her hooked up to power. Let's see what happens. I always hate these moments to see whether you fix something or blew it up. Let's see. Click. Yeah, there's the relays. Let's give it a minute to see if 6 is going to fire off by itself. And also, while we're taking a look at this, I should note here, let me try to move this camera down a little bit so you can see that display a little better. There. Okay. I should note that if there's something wrong with the CPU in one of these units, when you turn it on, this thing will show ERR and then a number. And usually when you see ERR and a number, it can be pretty bad. That means a failure or something wrong with one of the chips in there. And most of those are Roland proprietary stuff, so could be bad. But we're good. This is normal operation. Number 6 is not fired yet by itself. I'm going to attempt to turn it now and see if it still works and if it's going to keep tripping. So let's turn it. It's working pretty good right there. Let's go up about halfway. And that's exactly how it's supposed to work. It's not supposed to keep tripping like if you saw earlier. It would show 15, then it would show 6, and randomly back and forth. It's not supposed to. It's only supposed to show knob 6 when I turn knob 6. So I'm going to do it this way so you can see. I'm going to turn it. Let's call it 99. That's remember this is reverb time, so 99 is the max. And you see it goes right back to 15, which is our memory number. So I can go to like, let's see, memory number 1. And then when I move reverb time now, you'll see knob 6 and the settings should be around 99. I'll jump down to 20. Let's see. Yeah, I'll see it has a different algorithm here. So I got 20. My adjustment's basically 20 to 0.1. Midway, I'm about 5. But that's fixed. That's exactly how that's supposed to work. Here's knob 7. You can see that it shows 7. And I've got some adjustment. And I'll quit adjusting. It goes back to patch 1. When I memory up, you'll see this flashing. And when it's in flashing mode, that's when I can save this new setting I have. If you keep going, it'll just go out of it without saving anything. So here's patch. Let's do patch 5 so it's less confusing. You'll see again, I'm turning knob 6, so 5 will turn to a 6, and you'll see my adjustment over there. I can go to 99 on this one. Down to around 0.7 it looks like. So let's go to 15, 16. And yeah, that's fixed. Awesome. I'm so glad I found that. It was kind of an around the bend thing. I don't feel bad about replacing the pot, but because I think that honestly was something that could have been wrong, but it's fixed. Okay, I've put the DEP-5 back in the rack now, just to test it out with the signal chain here. I haven't put the ears back on it yet, just in case anything else went wrong with it. It seems to be working fine though. Let's go ahead and hear it. First, you'll hear the dry signal. That's the dry signal. Let's kick the reverb in and see what it sounds like. Well, it's definitely working. Oops, speaking it out a little bit there. Yeah, it's definitely working. Let's try something with a little delay and reverb on it. See what we get then. And that, ladies and gentlemen, is the Roland DEP-5. Pretty cool. It's fixed.